Behaviors occur all the time, every day, and emotions and motivation are underlying them. Okay, but what are emotions and what is motivation? And how do they work together? It's obviously quite complex. You think, why do you go to school? Okay, or why do you drag yourself out of bed in the morning? Or why do you say yes to that person that asked you out on a date? Okay, we're going to look into this. We're also going to look at stress in this unit. Okay, and it is coming up right now. All right, I hope you're motivated to get going. We look at motivation and what is it? And what are the perspectives useful for studying motivated behavior? So motivation basically is a desire or a need to conduct your behavior, to direct your behavior. Okay, so when we look at it, our early theories of motivation were always an instinct. It was a fixed pattern of what we did. And we look at animals, like many animals, the salmon swim back upstream to lay their eggs where they were born. Or birds fly south in the winter, and we thought instincts were kind of the same thing in humans. So although humans do contain kind of instincts, they're not really outside agencies that are directing behavior, which kind of failed to explain a lot of things. They went to great lengths, saying things like if we wanted to pat ourselves on the back for something that we've done, that would be an instinctual desire for us to make ourselves feel good. Okay, but it doesn't really fit all of our behaviors that we have. So eventually this was kind of replaced by the drive reduction theory. The drive reduction theory says that basically we have a need, and then that need creates a drive, and then it motivates our behavior for a drive reducing behavior. So in our example, we have a need for food or water, obviously, or we die, and which creates hunger or thirst, which is the drive, and we strive to fix that by eating or drinking. Now, homeostasis is the idea. Internally, we want to keep everything the same. So it monitors, and for example, our body temperature needs to be regulated to about the same temperature. Our blood sugar level in our circulatory system needs to stay about the same. So homeostasis is that idea of keeping things the same in our body. And so this is probably what causes these drive and then our reducing behaviors bring us back to homeostasis, which leaves us satisfied. Now, incentive is some kind of thing out there to make you do this. They can be good or bad things, actually. Most incentives we can think of, that you probably think of, are probably good ones. There's an incentive to win the prize, so we work hard to win the prize. But there can also be an incentive, like, for example, if a grizzly bear is chasing you, there's an incentive to run really fast. Okay, so they can be positive and they can be negative. Another theory has to do with optimum arousal. Okay, so the amount that we're kind of pumped up kind of thing. And we, all of us have different kind of levels that we want to maintain ourselves at. And if we sit around and we're doing nothing, some of us get so bored, we'll go out and try and do something else. Those people that love to do the very risk-taking behaviors, skydiving and, cliff diving and all those kinds of things that are quite dangerous, they have a high optimum level of arousal where other people don't. But if we sit around and we don't meet that level of arousal, we become motivated to monkey around like our monkeys down here. Have no particular reason. There's just a lock sitting there. They had nothing to do, so they're bored and they need to be aroused, so they do this. Which leads to the Yerkes-Dodson law. And the Yerkes-Dodson law basically says there's your performance on a task will increase if your arousal goes up to a certain point, and that certain point depends on the task you are doing. So for example, let's use sports as an example. If you're a football player, a lineman, and your job is to be physical and you don't have to think a ton about it, it's good to be totally hyped up. Football, you bet. You're going to go get them, smash them. Okay, so the higher the optimum level, the better on that, your performance is going to be better. But say you're a golfer trying to sink a 4-foot putt, golfers don't get all hyped up like that because that ruins their concentration and basically screws them up. You don't see golfers going, "Oh yeah, 4-foot putt, gonna go get it." Anyways, and generally what it is, the more skilled type of things take less of a level of arousal, the more skilled, and then the less skilled things require more arousal to perform well on them. So it depends on the task. So, which lead to another theory, which is Abraham Maslow's hierarchy of needs. And the hierarchy of needs looks like this. And basically, what he says is that you have to, first of all, achieve the needs at the base of his pyramid or his hierarchy, and then you can worry about the next needs. So he would say we need physiological needs met, hunger, thirst, air, all those kinds of things. And then we would worry about our safety needs. And once we met those, then we can worry about belongingness and love needs. Then we can go to esteem needs, and then self-actualization, which is kind of the goal of a lot of the Maslow is a humanist of the humanist philosophy. They added another one in here, which is self-transcendence needs, which is a need to find meaning and identity, which is actually beyond yourself. Okay, so they say you must follow these in order. However, we have found that there are people that don't follow this order, so that's a criticism of this hierarchy of needs. However, you will see this in every single intro to psych textbook, and you need to know the different levels of Maslow's hierarchy. So learn it. Hope I've motivated you. So here are the motivational theories of strengths and weaknesses. The first one was the instinct theory, which actually we call the evolutionary theory right now. Evolutionary, it helps explain behavioral similarities due to adaptations from our ancestral past. Okay, we have an instinct to eat food, obviously, because that keeps us alive. So this would be evolutionary. It also explains animal behavior better than human behavior. We have a lot fewer true instincts than a lot of animals do. So how does this work with humans? Drive reduction. Okay, it's a motivation to reduce a need that we have, but it doesn't explain why some motivated behaviors increase arousal as we are doing the behaviors. The optimum arousal theory explains that motivated behaviors may decrease or increase arousal, but it doesn't explain that our motivation to address our more complex social needs, how we need to fit in and those types of things. The hierarchy of needs incorporates the idea that we need to go through steps. Some needs are more important than others. However, the order of needs may change in some circumstances. And evolutionary psychologists note the absence in the hierarchy of the universal human motives to find a mate and reproduce. Okay, so some of our motivations, we're going to look at hunger first of all. Here are the objectives. Why you get hungry? Why do you eat? Why do you overeat? Why do you not eat? So first of all, we want to find out, what makes people hungry. So Washburn, with his partner Walter Cannon, Washburn, he agreed to swallow a balloon that has sensors on it. So they would inflate, he would swallow the balloon, they inflate the balloon. Then they asked him, when you feel hungry, you feel little pangs of hunger, could you hit the key? And so when he hits the key and they measured against his stomach contractions, they found that they actually correlated very well. So when he was feeling hungry or had those pangs of hunger, his stomach was contracting. So he thought, stomach contractions are what make people hungry. However, there are situations now where we've had people with their stomachs removed, cancerous stomachs, and they still get hungry, so it really doesn't explain the whole picture. There's a lot of body chemistry and our brain are really involved in this. And there is insulin, which is glucose, which is what our body uses. It's the sugar that we use to burn for energy. Insulin helps us control the amount of glucose running through our body. Our hypothalamus contains structures that will tell us whether we are hungry or we are not. And it seems like the hypothalamus part of it are specialized. So we have the lateral hypothalamus, which basically, if stimulated, will tell you that you are very hungry, that you need to eat. Whereas the ventromedial, there's missing an N right there, ventromedial hypothalamus says that you are full. Okay, so how can you remember this? Okay, first of all, lateral hypothalamus, LH, means large hunger. You stimulate it, you have large hunger. Ventromedial hypothalamus, you can think of VMH for ventromedial hypothalamus, means very minimal or very minuscule hunger. So it's not. So you can see this rat on the left, our mouse here. His lateral hypothalamus has been stimulated. Okay, and he will eat and eat and eat until he basically kills himself. And this little diagram down here, hopefully you remember where your hypothalamus is. And now we've divided it where you can see the lateral and the ventromedial. So there's also hormones that are produced: ghrelin, insulin, orexin, PYY, and leptin. And all this leads to a couple theories, and we'll go over what each of these hormones do in the next slide. But what this leads to is a set point theory, which your set point theory basically says that there's a weight that you are biologically predetermined to be, and your body will work its way around that. More on that in a second. Your basal metabolic rate is how much energy you burn at rest. Okay, so if you spend a day at rest, how much energy does that require for you to stay alive? So with the set point theory, if your body is supposed to stay at a certain weight and you drop below it, what it does, it will send these hormones to tell you that you are very hungry, and it will also lower your metabolic rate. Okay, it can lower it significantly. And this is a lot of reason why a lot of times that a lot of those severe weight loss programs where people are losing 12 pounds in a week, doesn't work for them, because they lose their 12 pounds and stuff, but their brain then tells them they're very hungry and they don't burn the energy as fast, so they put the weight on very quickly. Okay, so that's the set point theory. Okay, so let's look at these hormones. We have insulin. Okay, this is secreted by the pancreas, which controls the blood glucose. Basically, diabetes is your pancreas is not working to secrete the insulin, and that's why you have to use insulin injections. Ghrelin is secreted by an empty stomach, so it sends "I'm hungry" signals to the brain. Okay, so your stomach is empty, so ghrelin is produced, and it tells your brain you're hungry. Orexin is a hunger triggering hormone secreted by the hypothalamus. So your hypothalamus secretes that and tells your brain to tell you that you feel hungry. Leptin is a protein hormone. It's secreted by fat cells. Okay, when abundant, it causes the brain to increase metabolism and decrease hunger. So the leptin says, we're pretty saturated here, so we don't need to eat as much. So we will send this message to the brain. PYY is a digestive tract hormone. Okay, so this is in your digestive tract, and it will send "I'm not hungry" signals to the brain. So they work together to try and keep your body in homeostasis. Okay, so that you have the right amount of blood sugar level. So our taste preferences, gets into why we eat. It really depends. There seems to be a biological predisposition for flavors in our eating, things that we prefer to eat, and it's based on our culture. All over the world, genetically sweet and salty things are something that most people like, because these are flavors of foods that will generally high in calories. And before civilizations, prehistorically, it made sense that when there was an abundance of this kind of food, we eat as much as we can so that we could last over the winter. Neophobia actually works around the world too. Neophobia means that basically we are usually unwilling to try new foods, or we're very leery of new foods. And this is true in animals as it is in people. Adaptive taste preferences we find in warmer climates. The recipes call for way more spices, so we like those flavors better there. And it turns out that is biologically adaptive, because it makes us that's what we can keep the meat safe from being rotten because of the heat. Likewise, in other places, the sweet taste, the glucose, again, is something to be attracted to. That sugar taste, sweetness, because it helps us store fat for times when there's not enough food. Prehistorically, when there was a lot of food around, it was a good idea that you ate a lot of it, but later on, there wouldn't be food, so you could live off the fat stores. This is just looking at the spices per recipe during the temperature, and you can see there is a correlation. But what kind of correlation do you think that would be, just looking at that graph? The coefficient, I mean. Remember that? If you don't, go back. Way back. Research design, stats. Okay, so what about situational influences on eating? There's other ones too. When you're out with people, do you eat more than you do when you're by yourself? And research has shown, yes, you do eat more when you are out with other people, usually at parties. and things like that, or social gatherings. And we tend to copy the other person's behavior, which we'll look at more when we get to social psychology. Unit bias is an interesting thing too. Can we reduce the amount of food we eat by our serving plates that we have? You know, instead of a big plate, have a small plate. Instead of a big ladle, have a small ladle. And yes, it actually does make a difference. It's not that, you know, people just take more, go back for more, for seconds and thirds because their plate is smaller. They actually will eat less because of that size. So that's one thing to do if you think you're overeating, is to definitely, change proportions by giving it the unit bias. And food variety makes a difference too. When there is a large variety of food, we tend to eat more. Okay, and again, this is biologically adaptive. When there's lots of, it triggers our brain because, again, you think prehistorically, when there's lots of food, it's a good idea to eat lots of food because there are times when there's not. So we tend to eat more when there's a big variety as opposed to a smaller variety. Okay, so if you want to eat less snacks, don't have a variety of snacks at home because that will trigger you to eat more. So obesity and weight control. Obesity is on the rise, as you probably have heard. The set point of metabolism thing is a big deal with this. Because, when you eat and your metabolism changes, this makes you put on weight so much faster. This is why a lot of those weight loss programs are actually detrimental to you losing weight. The only way to really lose it in an efficient manner is to lose a little bit over a long period of time. You need to really want to do it and understand that this is a lifestyle kind of change. Okay, the genetic factor, some of you may not like this, but if you want to see basically how your body's going to turn out, you should look at your parents, okay, because that's one of the best indicators. It doesn't necessarily mean that's how you're going to turn out, but there's a pretty good chance. And we find this with all kinds of twin studies and adoption studies as well. The social influence that you have, right? The food and activity factors. Being around lots of food with lots of people will make you eat more. Going to the grocery store while you are hungry will make you probably pick up a lot of those snack kind of items that aren't good for you much more than if you went on a full stomach. So these little tricks can and they will help. So we look at, obesity, and I'll give you the definition of obesity in a bubble there. I can't remember. I think it's a 50 BMI, body mass index, or is it 30? I'll put it up there. But we can see, all countries, it is growing. Here is Canada here, United States up here. And there is a fair amount of it, which is an issue. But, you think about all of the things that we have done to try and, we supersize our meals. We make sure we have extra large servings. We make sure, there's soft drinks, at the front of every store. There's impulse buying for candy and all that kind of stuff. And we put a lot of stock into this. And it's really difficult to avoid eating and overeating. The other thing I didn't mention, which I should have said, is sleep. Getting sleep helps your weight control because of those hormones that are released that we talked about in the states of consciousness section. Okay, I think we're going to leave it right there. I think we'll come back with the next video on sexual motivation, okay, which will be next time. Bye for now.